The bottom line, I simply want to make ever better car, no matter what kind of the powertrain they have.
The bottom line is simple. I want to make ever better cars, no matter what kind of powertrain they have. Even though technology is advancing at a rate that blows our minds, no one could have imagined a day when you could take water from the kitchen sink, pour into your car's tank, and then be ready to drive to the supermarket or even to another state. Yet Toyota's recent announcement about an engine that could potentially end the era of electric cars suggests that running cars on water is no longer just science fiction. But what are the odds of a car running solely on water, without fuel or electricity? Toyota's new water engine is a groundbreaking innovation that could reshape the automotive industry. This mind-blowing vehicle works through an advanced electrolysis process that converts water into hydrogen, which fuels the engine. The power comes from a chemical energy release when hydrogen recombines with oxygen, producing energy while releasing only water vapor as a byproduct. This dramatically reduces harmful emissions and directly addresses global concerns about air pollution and climate change. Toyota's innovation promises a cleaner, greener future for transportation, aligning with worldwide efforts to fight global warming. While electric vehicles, EVs, have long been praised for their zero-emission performance and reliance on renewable energy, Toyota's water-powered car offers unique advantages. Unlike EVs, which depend on lithium-ion batteries that require frequent charging from the electrical grid, this technology harnesses water, an abundant and renewable resource. The electrolysis process itself can even be powered by renewable sources such as solar or wind, making the system more sustainable. Furthermore, while electric cars still pose environmental challenges due to production and disposal of batteries, Toyota's water-powered engine avoids these problems entirely. At a recent meeting in Japan, Executive Vice President and Chief Technology Officer Hiroki Nakajima announced Toyota's ambitious plan to transition from being just a car company to becoming a mobility company, one that provides people with multiple options for movement. He was joined by Takeru Kato, who leads the development of battery electric vehicles, and Mitsumasa Yamagata, who will spearhead Toyota's hydrogen car program as new factories begin operations. Toyota's hydrogen fuel cell cars already work by combining hydrogen stored in the vehicle with oxygen from the air to generate electricity, with an important component called an electroneutralizer, ensuring the system runs efficiently. This bold new approach signals Toyota's determination to redefine the future of transportation. Hydrogen fuel cells are efficient and safe, since they don't require much energy and produce no harmful byproducts. One of the biggest advantages of this process is that it eliminates the need for large, heavy tanks to store hydrogen. The electrolyzer can generate hydrogen on demand, making cars lighter and more efficient. To use hydrogen fuel effectively, however, some parts of the car's motor must be modified. The fuel injectors, which spray fuel into the engine, need to be adapted to properly spray hydrogen, while the engine block and cylinder head must be reinforced to handle the high pressure of hydrogen fuel. Other components, such as valves and spark plugs, also need special designs to ensure smooth and safe operation. Although we will explore the technical process in more detail later, it's important to note that Toyota's water engine stands out compared to other hydrogen-powered motors because storing water is far easier and cheaper than storing hydrogen. Hydrogen is a gas, which means it requires special, high-pressure tanks that are heavy, expensive, and prone to dangerous leaks. Water, on the other hand, is a liquid that can be stored safely without specialized containers, making it more practical. This simplicity and safety make the water-powered motor versatile, suitable for small cars, large trucks, and even power plants, while also reducing reliance on fossil fuels and cutting harmful emissions, ultimately making a more sustainable option for both transportation and energy generation. However, the idea of powering vehicles with water is not entirely new. Before Toyota's recent steps, several others attempted similar innovations, though many of their claims turned out to be exaggerated or fraudulent. In 2008, a Japanese company called Genapax announced a car that could run on water instead of gasoline or diesel, claiming their system split water into hydrogen and oxygen to power the car. But experts discovered the technology also required a special material called metal hydride, meaning it wasn't truly water-powered, and Genapax never provided solid scientific proof. Scientists pointed out that water is highly stable, and splitting it into hydrogen and oxygen requires significant energy, making the claims doubtful. This echoed the story of Stanley Meyer, who in the 1980s claimed to build a dune buggy that ran on water. His claims were never substantiated, and in 1996, he was convicted of fraud. Similarly, in 2002, a company called Hydrogen Technology Applications introduced a device called Aquagen, which they initially marketed for safe welding but later claimed could power cars. Their theories lacked scientific backing, and the company eventually admitted the device could only improve fuel efficiency, not make cars run on water alone. Another company, Genesis World Energy, claimed in 2002 to have developed a water-to-energy device, raising millions of investors but never producing a working product. Its founder, Patrick Kelly, was jailed for fraud in 2006. That same year, a Sri Lankan man, Tashera Priyodasinghe, claimed he drove a car 190 miles using only 3 liters of water, with even the Prime Minister showing support. But he was later arrested for fraud when his claims were proven false. More recently, in 2022, Arianto Mel from Indonesia claimed to invent a device called Incuba, which supposedly turned water into hydrogen fuel capable of powering motorcycles for 500 kilometers on a single liter water. He also claimed luxury car makers like Lamborghini and Ferrari were interested, but scientists in Indonesia dismissed the device as impossible according to physics and found no evidence of car company involvement. Despite these repeated failures, false promises, and scams, many wonder if there has been a deliberate effort to suppress water-powered vehicle technology. While there is no definitive proof, the possibility is not far-fetched. The global energy industry, dominated by fossil fuels, is worth trillions of dollars, and the introduction of water-based fuel technology could threaten the financial interests of powerful corporations and stakeholders. These entities possess the resources and influence to suppress or discredit disruptive innovations. Fossil fuel companies, in particular, have a vested interest in maintaining their dominance and may lobby against or undermine alternative energy technologies to protect their profits. New and innovative technologies often face skepticism and resistance from both the public and the media. It is understandably difficult for many people to grasp how water could be used as a fuel source for vehicles, and concerns over safety, risks, and lack of understanding often lead to negative publicity and slow acceptance. Powerful entities may also exploit these fears to maintain control over the narrative and suppress disruptive technologies, with misinformation campaigns creating doubt and discouraging adoption. However, with Toyota publicly announcing its plans to develop water-powered cars while presenting scientific evidence to support the technology, we may be witnessing the dawn of a new era. Toyota's influence in the global mobility market, the trust it has built over decades, and its vast resources suggest that water-powered vehicles could soon become a reality rather than speculation. This effort stems from Toyota's commitment to staying ahead in a market that is rapidly shifting toward clean technologies, particularly with the rise of electric vehicles, EVs, from Chinese companies like BYD and Xiaomi. To remain competitive, Toyota has focused on advancing hydrogen technology, making it more efficient and sustainable. While many earlier claims of water-powered cars proved false or misleading, Toyota's ongoing research, including the successful hydrogen-powered Mirai, demonstrates that a sustainable future for transportation is possible, with more advancements still to come. When comparing progress in clean mobility, China and the United States currently lead in electric vehicle production. China, through aggressive government policies, major investments, and extensive EV infrastructure, has become the largest EV market in the world. Companies like BYD, NIO, and XPeng are spearheading this revolution, supported by subsidies, widespread charging networks, and advanced battery research. Millions of electric cars are sold annually in China, and the government's focus on reducing urban pollution and carbon emissions has reinforced its dominance. The United States, home to Tesla, has also made significant strides. Tesla's cutting-edge designs, technological innovation, and vast supercharger network have redefined the EV market, while traditional automakers like General Motors and Ford are now investing heavily in electric models. Despite these achievements, both China and the U.S. face ongoing challenges related to the environmental impact of battery production and disposal, as well as a reliance on sustainable energy sources to charge EVs. This is where Toyota's water-powered hydrogen car presents a unique advantage. Unlike battery electric vehicles, BEVs, that rely on large lithium-ion batteries, Toyota's system uses hydrogen fuel cells, which eliminate harmful pollutants by producing only water vapor. The benefits go beyond emissions. Hydrogen fuel cells can be refueled in minutes, compared to the hours required to recharge EV batteries, making them far more convenient for long-distance travel. They also offer higher energy density than lithium-ion batteries, enabling longer driving ranges while maintaining lighter vehicle weight. Moreover, hydrogen can be generated from renewable sources like solar, wind, and hydroelectric power, reinforcing the sustainability of the system. Toyota has also addressed some of the key barriers to hydrogen adoption. It's advanced. Electrolysis units use cutting-edge catalysts and materials to improve efficiency and reduce the energy needed to split water into hydrogen and oxygen, making large-scale hydrogen production more practical. For storage, Toyota has designed high-pressure tanks made of advanced composite materials that are both lightweight and extremely durable, equipped with safety sensors to detect and prevent leaks. Even the challenge of operating in cold climates, where hydrogen can freeze at very low temperatures, has been met with innovations such as heating elements and insulation built into the tanks to ensure reliable performance in harsh winter conditions. By integrating renewable energy into hydrogen production, Toyota's water-powered cars could operate with an exceptionally low carbon footprint, making them a truly green alternative to both fossil fuel vehicles and traditional EVs. Toyota's determination to push eco-friendly innovation underscores its vision of leading the global shift towards sustainable mobility and reshaping the future of transportation. Eco-friendly technologies rarely emerge suddenly, and Toyota's commitment to sustainability extends far beyond its work on hydrogen fuel cells. The company has been a pioneer in hybrid technology and the exploration of alternative fuels, particularly in developing hydrocarbons with reduced environmental impact. Conventional hydrocarbons such as gasoline and diesel are significant contributors to carbon emissions, but Toyota has been researching synthetic hydrocarbons and biofuels as cleaner alternatives. Synthetic hydrocarbons are created through processes that recycle carbon dioxide and hydrogen into usable fuels, effectively reducing net emissions, while biofuels, derived from plant biomass, algae, or animal waste, offer renewable and sustainable energy sources. Toyota has invested in improving the efficiency of biofuel production to integrate these fuels into its lineup, providing immediate solutions to cut emissions as hydrogen and electric vehicle infrastructure continues to grow. Alongside this research, Toyota has made major advancements in fuel cell technology, the cornerstone of its eco-friendly strategy. Hydrogen fuel cells generate electricity through a chemical reaction between hydrogen and oxygen, emitting only water vapor as a byproduct. Toyota unveiled its first fuel cell prototype in the early 1990s, and since then, the technology has become more efficient, compact, and cost-effective thanks to innovations in catalyst materials, membrane durability, and system integration. The company now holds over 5,000 patents in this field, covering fuel cell stack design, hydrogen storage, and hydrogen production methods, positioning Toyota as a global leader in sustainable transportation. A major milestone came in 2014 with the launch of Mirai, the world's first mass-produced hydrogen fuel cell vehicle. Named after the Japanese word for future, the Mirai reflects Toyota's vision for sustainable mobility. The car's hydrogen system consists of high-pressure tanks, a fuel cell stack, an electric motor, and a battery for energy storage. The stack, the heart of the system, converts hydrogen and oxygen into electricity, powering the motor while producing only water vapor. With a range of over 300 miles and a refueling time of just 5 minutes, the Mirai offers performance comparable to gasoline cars while being far more convenient than battery electric vehicles that require long charging times. By eliminating tailpipe emissions, the Mirai contributes to cleaner air and reduced greenhouse gases, and Toyota has worked to lower costs through improved manufacturing and partnerships to expand hydrogen refueling infrastructure. Beyond the Mirai, Toyota has developed hydrogen-powered buses and trucks, highlighting the versatility of this technology across transport sectors. The company is also applying fuel cells to stationary uses, such as generators and energy systems for buildings and data centers, further demonstrating hydrogen's potential beyond automotive applications. This holistic approach recognizes that a sustainable future requires not only innovative vehicles, but also supporting infrastructure and clean energy solutions. Central to this system is the electrolyzer, which uses electricity to split water molecules into hydrogen and oxygen. Water, composed of 2 hydrogen atoms and 1 oxygen atom, is separated when an electric current passes through electrodes submerged in it. The hydrogen ions migrate to the cathode, negative electrode, while oxygen gathers at the anode, positive electrode. This process is efficient, safe, and produces no harmful byproducts, only hydrogen and oxygen. The hydrogen is then used as fuel for the motor, where the power control unit regulates the flow of electricity between the fuel cell stack and the battery to ensure smooth acceleration, regenerative braking, and efficient energy use. The fuel cell generates direct current DC, which is converted into alternating current AC, by an inverter to power the motor. During braking, the motor functions as a generator, storing recovered energy in the battery. While electrolysis is not 100% efficient, traditional systems achieve around 60 to 70% efficiency. Advances in materials and catalysts have pushed this figure closer to 80%. Fuel cells themselves typically operate at 50 to 60% efficiency, meaning that overall, the water-to-electricity conversion efficiency in vehicles is around 40 to 50%. Despite this, hydrogen has a higher energy density than lithium-ion batteries, enabling hydrogen vehicles to achieve longer ranges than many battery electric vehicles. This makes Toyota's hydrogen approach both practical and promising as the world seeks greener, more sustainable modes of transportation. Toyota's plans for future mobility, under banner "Let's change the future of cars," reflect the company's ambition to transform itself into a full-fledged mobility provider. Central to this vision is a strong focus on hydrogen, with Toyota projecting that by 2030, the hydrogen markets in Europe, China, and North America will become the world's largest, with the global fuel cell market expected to reach around 5 trillion yen, approximately 5.7 billion pounds, annually. To capture a significant share of this market, Toyota is pursuing several key initiatives. In July 2024, the company will establish a new hydrogen factory, centralizing development, production, and sales functions under one leadership structure to streamline decision-making and accelerate progress. The hydrogen factory strategy has 3 pillars: localizing R&D and production in major markets like Europe and China to meet regional needs, strengthening alliances with leading partners to consolidate supply chains and reduce costs, and advancing next-generation fuel cell technologies to boost performance while reducing costs. Toyota aims to cut the cost of fuel cell stacks by 50% and expects further reductions if orders reach 200,000 units by 2030. Alongside lowering vehicle costs, Toyota is addressing the high cost of hydrogen production itself. Collaborating with partners, they are exploring new methods such as producing hydrogen from biogas derived from chicken manure and food waste in Thailand with Mitsubishi Kokoki Corporation and Toyota Tsusho Corporation. They have also developed a new water electrolyzer based on Mirai fuel cell technology to make hydrogen production more efficient. To expand hydrogen adoption, Toyota is creating a multi-hydrogen tank system designed for easy installation across different vehicle types and sizes, enabling both new vehicles and existing ones to be converted for hydrogen use. Their focus extends particularly to the commercial sector, with plans to standardize tank sizes, develop liquid hydrogen tanks for large vehicles, and accelerate the rollout of hydrogen-powered trucks and buses. Toyota has even developed a trial hydrogen engine vehicle, licensed for public road use in Japan, as part of its push toward hydrogen combustion engines and carbon neutrality. Overall, Toyota is not only working to reduce hydrogen fuel costs, but also partner with industry players to promote large-scale production, distribution, and adoption. By creating customer-focused bases in major global markets, Toyota intends to make hydrogen vehicles and product affordable, practical, and widely available. With these ambitious steps, Toyota is positioning itself to lead the shift towards sustainable transportation, and its plans suggest that engines running on hydrogen and perhaps even water may soon become a reality.